A warm good evening to all. So we'll start a local recording. So now let's start the session. So this is a final week problem solving session. So I'll be here sharing some questions from all the weeks. Mostly concentrated on the initial weeks because we have revised it long back. So I've taken more questions from the initial part and then one or two questions from the final part because we have basically discussed about the durability and then mineral admixtures. So after that, we have read about fresh concrete and hardened concrete properties. So this week I'm more concentrated on the cement chemistry part much. So let's see the questions. Let me share my screen now. And tomorrow we have one more live session with the course instructor itself. Please again request all to join the live session. So just a minute. Yeah. So now mouse is not working. Sorry. So this is going to be the final problem solving session for the NPTEL course Advanced Concrete Technology. So this is the first question for the week. So here is going to be most of the questions are going to be true or false question. So the first statement is the burning rate of aspirant clinker is relatively slower and the size of allied phase is larger when compared to modern clinker. So this statement, let me start the timer for 30 seconds because we have more number of questions. So let me start the timer for 30 seconds. Please give your answers in polls and chat box. To the people who joined new, to the bottom right corner of the screen, there is an option called activities. If you click that, we can find polls. Or else you can give your answer in chat box also. No problem. Time is up. See the class response. Voice not clear. Okay. Is my voice clear now? I request everyone to mute yourself, particularly Bharat Guluswami. Please mute yourself. Yeah. Because it will disturb the class as well. So I request everyone to mute yourself. And if you have any query, you can please stop me by any time and you can place your query. Okay. So I hope my voice is clear now. And answer is false. Okay. Let's see from the polls as well. So people have joined new and let me show here once. So to the bottom corner of the screen, there's an option called activities. If you're joining from mobile phone, there is 3 dots, right? For more options. If you click that, you can find the activities. So to the bottom right corner of the screen, there is an option called activities. If you click that, we can find polls. Okay. So in the polls, questions have been already launched. Yeah, already 6 people have given your answer. Okay. I thank you guys and brush up the basics. I request everyone to go back to the initial lectures and please watch the videos or go through your notes because I'll get questions from all the part, not only from the recent part, which is covered in the recent time. Okay, so the correct answer is false. The correct answer is true because the burning rate of aspirant clinker is relatively slower. That's why the crystals of allied is comparatively larger, and then the size of pellet is hello. Hello, am I audible? Okay, so the burning rate will be comparatively slower compared to the modern clinker. And in aspirant clinkers, the type of rotatory kiln used is like the kiln used is vertical kiln, and when we see modern clinker, the kiln used is a rotatory kiln. Sorry. Okay, so in aspirant clinker, the kiln is going to be vertical kiln, so the loading of material is not a continuous process. But when come to modern clinker, the modern cement plants have a rotatory kiln where the loading and unloading will be continuous. Okay, the materials will be loaded from one part of the rotatory kiln, and then the output will be continuous. Okay, and the burning rate will be comparatively slower, relatively slower in aspirant clinker when compared to modern clinker. The size of allied phase will be larger and the billet is smaller. When we compare modern clinker, the allied size will be very small compared to the aspirant clinker. That's the reactivity is higher. Okay, so now let's move to question 2. So here it's going to be an association listening type of question. So here there's one statement saying that cement industry contributes 7 to 8% of man-made carbon dioxide emissions. Okay, that is assertion. The reasoning is they're giving us transportation of raw materials is the major reason for carbon dioxide emission from cement industry. Okay, let me start the timer now for a minute. So if you find both is right and R is a correct expression, you can go for option A. And similarly, if R is not correct reasoning for a statement A, then you can go for option B. And if you find A is true but R is not true, then you can go for option C. And if you find A is false and B is true, then you can go for option D. If both is seem to be false, then you can go for option E. So we all know that cement industry is contributing about 8% for man-made carbon dioxide emissions. So that's why we have to concentrate how we can reduce such carbon dioxide emissions with global warming as a environmental concern. And so as clearly explained in the lecture that how does cement production is contributing to carbon dioxide emission, what are the processes are contributing to carbon dioxide emission as well. Time is up. So let's see the correct answer. The correct answer is option C. The cement industry contributes 7 to 8% of man-made carbon dioxide emission is true. But transportation of raw materials is not the major reason. The major reason is, so we all know that calcium carbonate is one of the major raw material in cement production. So if you calcium carbon dioxide, so around like if you take 1 ton of about 60 to 70% of the raw material will be limestone, right? So about to produce 1 ton of Portland cement, 1 ton of carbon dioxide will be released. Okay. So calcining the raw material is one of the major reasons for carbon dioxide emission. Transportation also contributes, but it is not the one of the major reason for carbon dioxide emission. Okay. So now let's see the class response here. Okay, most of you have picked option A. You might think that transportation is not the major reason, but it's not the major reason. It's one of the major reasons, but it's not the major reason that contributes to carbon dioxide emission. Let's see the polls as well. Okay, people will have opted for. Okay, some people have thought that R is not a correct reasoning. Like we cannot say R is not a correct reasoning because transportation also contributes, but it's not the major contributor. That's it. Okay, now let's get back to the PPT. Okay, so now let's move to the next question. So here the question is, which of the following phase is found first in the rotary kiln and OPC production? Okay, so let me start a timer for 30 seconds. Okay, so please give your answer in polls as well as chat box. Try to give your answer in polls because I'll get a collective response whether you get to understand the topic or not. Okay. If not possible, please give your answer in chat box. So we all know that C3S, C2S, C3A, C4S, all these phases are found. But which phase is found first in the rotary kiln? Time is up. Okay, let's see the correct answer. The correct answer is C2S. Around 1200 degrees Celsius itself, C2S is formed. Okay, so then C2S, some of the cities will be recombining with the calcium oxide there to form calcium tricalcium silicate. But at 1200 degrees Celsius itself, C2S is formed. And C3 and C4A or C4A, both these aluminate phases are not formed in the rotary kiln itself. It's formed on cooling the clinker from the rotary kiln. Okay, it's formed while cooling. This will be found in the ground masses together. So it's like a flux which helps in the formation of C3S, both C3A and C4A. So these phases will be formed once on cooling, not within the kiln. Okay. So now let's move to the next question. This particular question has more than one option. Okay. So the question is, which of the following phases are responsible for early age strength development in cement concrete? So we all know that all these phases contribute, but which of the following phases is responsible for early age strength development? Okay, so it has more than one option. Let me start the timer for 30 seconds. Please give your answer in chat box. Time is up. Let's see the first response. Okay. And some people have typed the answer. Okay. It's okay to type the option number itself. You need not type the complete answers. Okay. Let's see the class response to the previous question as well. Yeah, most have given the right answer for the question. Yeah, it's nice. Let's get back to the PPT. So the correct answer is nothing but option A and option C. We all know that C3A tricalcium aluminate is the very fast like it reacts very fast compared to the other phases, and then C3S is responsible for the earliest strength development. Both C3A is also responsible for the earliest strength development because of its fast reactivity. Okay, so it reacts very fast, so that is one of the reasons which it contributes to earliest strength development as well. Not only C3S contributes, okay, and we all know that C2S is responsible for the later age strength development. Okay. Now let's move to question number 5. So here the question is, high reactivity of C3S is due to irregular crystal structure of C3S. Okay, which depends on, you have to find the reason. Okay, so let me start the timer for 30 seconds now. Let's see the answer. You have to find which is the correct reason for the irregular crystal structure of C3S here. Time is up. Let's see the class response. Okay, most of them have picked both option A and B. Yeah, that's the right answer. Okay, we have picked option D. Okay. Okay, let's see the solution. So the correct answer is both option A. So the impurities present in trication silicate and also the heating rate within the rotary kiln and the cooling rate of the C3S clinker. All these factors affect the crystal structure of C3S, and in the irregular structure of C3S phase is responsible for the high reactivity. Okay, so now let's move to question number 6. It's going to be a true or false question. So the statement is Portland pozzolana cement needs less curing than ordinary Portland cement to reach the pore refinement as to the level of OPC. Okay, so they say that Portland pozzolana cement requires less curing. Let me set the timer for 30 seconds. Then let's see the class response and the solution. Portland pozzolana cement means it will have pozzolanic material replaced in the ordinary Portland cement up to 25%, 25 to 30%. And in India, mostly the cement has about 25% of fly ash replaced in ordinary Portland cement. Time is up. Let's see the class response. Okay, most of them picked up false is the right answer. Okay. Because we all know that it requires more curing. Okay, that's nice. Now let's get back to the PPT. So the correct answer is false because Portland pozzolana cement needs more curing than OPC because a number of we all know that from ordinary Portland cement hydration, Portlandite will be produced. That Portlandite will react with the reactor silica from the pozzolanic material. So it requires more time for the additional CSH to form. Okay. So now let's move to question number 7. So question number 7, the C3S and C2S phases react with water to form CSH gel and calcium hydroxide phases. So the outer CSH is formed by which process? Dissolution or water diffusion, and the inner CH is formed by dissolution or water diffusion. Which is the right answer? If you're picking option A, it says that outer CH is formed by dissolution and inner CH is formed by water diffusion. And then if you pick option B, it says that CSH, outer CH is formed by water diffusion and then inner CSH is formed by dissolution. Okay, so let me start the timer for 30 seconds. All these questions are launched in polls. Time is up. Let's see the class response. Okay, most of you picked the right answer. Yeah, most of you picked the right answer. Okay. Because the right answer is option A. Because outer CSH means it's formed on the outer region of the unhydrated cement grain. Okay, so initially the cement grains try to dissolute to the solution, to the water initially, then it converts water to pore solution because it contains ions now. So the outer CSH will be on the outside of the cement grain. So it undergoes dissolution, forms the outer CSH. And coming to inner CSH, the water should break the barrier formed by the hydrates around the cement grain and it has to diffuse. So inward water diffusion happens, then inner CSH will be formed. Okay, and we all know that outer CSH is more porous because it undergoes dissolution from the reaction products. When we see inner CSH, it is more dense because water gets into the unhydrated cement grain and then it reacts to form inner CSH, and comparatively inner CSH is more denser. Okay, so now let's move to question number 8. So aluminates, which is nothing but tricalcium aluminate and tetracalcium alumina ferrite, aluminates in the absence of dash hydrate rapidly to produce calcium aluminate hydrate, which causes flashlight. Okay, so what Flash said, we add one ingredient, that is what in the absence of that particular ingredient aluminates hydrate rapidly. Okay, you have to give the right answer. Let me start the timer for 30 seconds. We also say it as a set controlling agent. It's a very simple question. Thumbs up. See the class response. Okay, most have picked the right answer. Nice. So gypsum is not added to the rotary kiln in the production of Portland cement. So it's added once the clinker is cooled. It's added in the ball mill to produce the cement. Okay. Gypsum is not one of the ingredients that's not added to the rotary kiln while producing this while producing ordinary Portland cement. Okay. Now let's go to the next question. So question 9 have to. This is one of the STEM micrograph taken from the lecture PPT. So now you know that in backscatter electron image, the brightest phase indicates a denser phase, and darker phase means uh, it's the pore. Okay, so here there is some spot, right? The darkest means it is a pore. It doesn't have any material. The densest phase will have much. It will be. So the brightest phase. I think I've said the answer also. Okay. The denser phase will be more brighter, and the darker phase indicates a pore. Okay. So please mark these. Please label these parts here to the point which is pointed in the figure. Let me start the timer for a minute. Here you see there is not much color, any gradient, it's completely gray in color. And then if you see B, inside it's partially white, but it's pointed in the gray face here. So there is some color change here. And coming to C, the outer face is slightly gray, but the inner part is completely white, and the C is pointing to the brightest face. Okay, so coming to D, it's pointing in the brightest face, but along with the ground mass. So just think what is the right answer. Okay, let's see the solution anyway, and then see the class response. So the first part doesn't have any gradients, which means it's a sand particle. Okay, so does not have any gradation and it's larger in size also. And coming to option B, B is nothing but CSH because the outer part it's hydrated and the inner part still remains as unhydrated cement grain. And unhydrated cement grain appears to be very bright in the backscatter electron image compared to CSH. And Portlandite also appears to be in bright phases, but since it's mixed with the ground mass will have both H8 and 8 in A form phases, so it will be mix it with the gray phases, but it will be a bright spot. So Portland will not be present mostly in the uh, 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 in between the space between the aggregate and the cement phase. Okay, interfacial transition zone is the place where Portland will be present because it has more space for the Portland crystal to grow. Okay, so now let's move to the next question. It's again going to be to our first question. So here the statement is the water present in capillary pores are classified as free water. So whatever water present in the capillary pore is classified as free water, and the removal of that water does not cause any shrinkage strength. Okay, so let me start the timer for 30 seconds. Can we say all the water present in the capillary water is free water? And then does the removal of that free water will not cause any shrinkage strength? See the solution. The correct answer is false. Some of you think it is true. No. The water present in the very fine capillary pores. So the water present in the capillary pores is classified in two types. One is free water, one is water by capillary suction. Okay, so the very fine, the very small capillary pores, the water present in such capillary pores will be under suction. Okay, capillary tension will be there. So because of which the removal of water from very small pores will cause shrinkage strength. Okay, so the water present in the larger capillary pores will not cause any shrinkage strain, which is classified as free water. But the water present in the very small capillary pores is termed as water under capillary suction. Okay, so which does cause some shrinkage strain. So the answer is false. But the removal of free water does not cause any shrinkage strain. Okay, but all the water in capillary pore cannot be classified as free water. Let's see the class response. Most important is true. Yeah. Hope you guys got it clear now. Okay, most of both aggregate and sand are same. Okay. Okay, fine. That's nice. That's a good attempt. Yeah, most people thought that it's true, but it's not. Okay, it's partially true. Even if it's partially true, it's false. Okay. Next is question 11. So the type of calcium sulfate gypsum affects the compatibility of superplasticizer. Is that true? Let me start the time after 30 seconds. Normally we use calcium sulfate gypsum as a controlling agent. So the type of calcium sulfate will affect the compatibility of superplasticizer. The answer is true because both calcium sulfate as well as superplasticizer, like calcium sulfate will have sulfate in it, and superplasticizer will have sulfonates in it. Both of these sulfates and sulfonates will uh, will concentrate on the alumina sites from calcium aluminate. Okay, so during that time, there will be conflict between the calcium sulfate from the calcium sulfate gypsum and then sulfonates from the superplasticizers. So we have to consider the type of calcium sulfate we are using, and then how we can reduce the compatibility issues between the superplasticizer and the gypsum type. Okay. So now let's see the class response. True. question. Next question, which of the following methods are used to increase the efficiency of SNF based water reducers? Okay. We know that there are different types of water reducers. SNF is one among them. It's a second generation water reducers. So they're saying that which of the following methods can be used to reduce the efficiency, can be used to increase the efficiency of SNF sulfonyl naphthalene formaldehyde water reducers. Okay, let me start the timer now for 30 seconds. There are different options here. Using the dimers and timers, which are low molecular weight SNFs, and then maintaining the sulfate and beta position. And option C is both A and B, and option D is none of them. So please pick the right answer. Time is up. Let's see the solution. So the correct answer is both option A. We have to reduce both the dimers and timers, which are low molecular weight SNFs, which need to be removed. Centrifuging is one of the process by which we can remove the lightweight particles out, lightweight matters out, and then maintaining the sulfate in the beta position, reduces the increase the efficiency as well as decreases the compatibilities as well. Okay, so let's go to next question. Before that, we'll see the class response. Okay, most of you think only it's option B. Okay. It's both option A. Okay, most of you picked the right answer. That's nice. Okay, now let's get back to the next question. So moving to question number 13. So question number 13, it says that high alkali content cement is favorable for SP compatibility with cement. SP is nothing but superplasticizer. Okay, high alkali content cement is favorable for superplasticizer compatibility with the cement. Is that so? Let me start the timer for 30 seconds now. Is high alkali cement content is favorable for workability and SP compatibility? Is that so? Let's see the class response. Most of you picked true. Okay. Let me add the poll over here. Okay, some people have picked false as well. Let's see what's the right answer. So the correct answer is false. It's not true because high alkali content will affect the workability. If normally even high alkali cement is not favorable for workability, so it also affects the SP compatibility with cement. So one of the techniques to reduce the compatibility issues is reduce the alkali content and also reduce the, so normally fineness is related to reactivity, right? Increasing the fineness will increase the reactivity, but increasing the fineness will not always is favorable. Okay, we have to moderate the fineness of cement such that there is no compatibility issue between the SPs and the cement. Okay, because high fineness leads to absorb more SPs for the given workability. So then if it absorbs more SPs than required due to fineness, then obviously we can get the workability, but end of the it will cause retardation as well. So we have to think about different elements when it comes to workability. Okay, so now let's move to question number 14. It says that second generation high range water reducers, which is nothing but sulfonated naphthalene formaldehyde, sulfonated melanin formaldehyde. Okay, second generation high range water reducers requires a minimum of 25 to 50 ounce slump for suitably acting on the cement paste. Okay, let me start the timer. So one such question is already discussed in the normal problem solving sessions, and we know that third generation high range water reducers does not even require a slump. Even zero slump it can work on. We are talking about second generation high range water reducers. They are saying that it requires a minimum of 25 to 50 slump to work on. Let's see the answer, then see the class response. The correct answer is true. Yeah. When it comes to third generation high range water reducers, even it can work on zero slump, but when it comes to second generation high range water reducers, it requires at least 20 to 50 ounce slump. And if we see the first generation, it requires at least 75 mm slump to work on. Okay, with the second generation high range water reducers, with this 25 to 50 mm slump, we can increase it up to 50 mm slump. Okay, so now let's see the class response. Coming to pose. Without exploring the questions, the people started giving answer for the many questions also. Okay. Most will make the correct answer. That's nice. Okay, now let's move to question number. Next question. Going to question number 15. Question number 15 says that shrinkage reducing admixtures work by increasing the surface tension of the liquid in pores. Pores are nothing but the capillary pores and fine gel pores and the cement concrete. Okay, so saying that shrinkage reducing admixtures it works by functions by increasing the surface tension of the liquids. Okay, let me start the timer for 30 seconds. Please give your right answer. Okay, now how shrinkage reducing admixtures work? You know the answer. Let's see the solution, then we'll see the class response. The correct answer is false. Because shrinkage reducing admixtures work by reducing the surface tension. So here know that a movement of water will be there inside cement concrete from hydrated phase to unhydrated phase. Okay, so like water will be mixed with cement, so cement starts to hydrate. So there will be unhydrated phase as well, right? So water has to move from the hydrated phase to the unhydrated phase for hydration. So that is how it works. So then a movement of this water to the very small pores causes capillary tension, which causes crack, right? So if we reduce the surface tension of the liquid in the pores, even it passes through the small pores, it will not cause capillary tension, and then it will reduce the cracking. So it reduces shrinkage as well as cracking. Okay, the shrinkage reducing admixtures work by reducing the surface tension of the liquid and not by increasing. So the statement is false. Let's see the class response. Okay, if you people have thought it's true. Okay, I hope you guys got it right now. I think there is some extra response here as well. Okay. Going to the next question. here the statement is the unburned carbon content in fly ash affects the workability and air entrainment. Okay, so you all know that fly ash, when coal is burned in thermal power plant, they get fly ash, and there will be some unburned carbon content left in the fly ash as well, which is measured with the help of loss and emission test. Okay, loss and emission values indicate the it's related to the unburned carbon fraction in the fly ash. So the unburned carbon extent in fly ash affects the workability and air entrainment. Is that so? Let me start the timer now for 30 seconds. Let's see the solution and then the class response. So the correct answer is true. It affects the workability as well as the air entrainment. So in the next question, let's see the class response. Goes to the picture one. Okay, most of you pick the right answer. Can you add the PPT? So the next question is, you have to, it's a understanding based type of question. You have to read through the question to give the answer properly. So consider a concrete sample that is subjected to acid attack. We have seen acid attack is one among the durability problems. So just it's a recently covered topic. Acid attack on concrete results in salt formation. So in this particular case, which is water soluble, they can be water soluble as well as water. They can be insoluble as well. So in this particular case, it's the water soluble one. So will there be a moss loss or a moss gain with continuous exposure to acid environment? Okay, this is the question. Please give an answer. Let me start the timer for 30 seconds now. It's a very simple question if you understand it. Let's see the solution then the class response. The correct answer is moss loss because we know that acid attack on concrete results in salt formation. Okay, some salt will be formed. In this particular case, it's going to be water soluble one. So since water soluble and it is a continuous exposure with the acid environment, so it's try to resolute with the external acid environment. It will be liquid, right? So it will try to go out, like it will try to dissolve in the water from the outside. Like water with acid environment means the pH will be less than 7. So in such cases, there will be moss loss. If the salt is not water soluble, then what will happen? So what will happen is then there will be moss gain initially. After some time, since there will be expansion due to the additional acid products formed, then there will be expansion, cracking. Then the cracking will lead to affect the hydrates inside. Then finally there will be some moss loss due to destruction of the concrete structure. But normally, if it's going to be a water soluble salt due to acid attack, then there will be moss loss. And then if it's a water insoluble one, usually there will be moss gain only. Okay. So now let's see the class response. Okay, most of you have given the right answer. That's nice. Okay, let's see the next question. Here's question number. Okay, here's question number question, you have to type the answer in chat box. So the question is, the carbonation resistance of cement concrete with silica fume is better than cement concrete blended with fly ash. Okay, this is a statement which is discussed in the class as well. In the lecture, it is clearly explained. The carbonation resistance of cement concrete with silica fume is better than cement concrete blended with fly ash. Why? Why is it? Let me start the timer for 2 minutes. So after 2 minutes, we'll see the solution. Please type your answers, or it will see after 1.5 minutes, okay? So please type your answer in chat box. This question is not launched in polls, okay? So please give your answers. Time is up. See your class response. There are some answers. Let's see. Denser particles. Dense particles occupies the space. Particle size are denser, so water penetration is not. Particle size are denser. Particle size can be large or small. It can't be denser. Okay, maybe you're saying pore refinement. Pore refinement also because it's denser. Okay, so you're talking the size of the small and large. That is, they're not high, but how does it go? Silica will contain fine pores which provide resistance to carbonation. Yeah, that can be one of the reasons. Yeah, dense particles will mix up with concrete with fly ash, but water penetration is not. Okay, there are some understandings, but there's more confusion in the class. Okay, now let's see what are the reasons that can contribute to carbonation resistance of cement concrete with fly ash when compared to other blended systems. Okay, let's see why. Because the typical replacement level of silica fume is limited to 5 to 15%. Mostly it's 10% in most of the cases. Whereas with fly ash, the typical replacement levels are 25 to 30%. Okay, so more replacement leads to reduction in the Portlandite content available. Okay, so if more amount of flags is replaced, then it will consume all the Portlandite, right? There will be no Portlandite available for like we all know that the carbon resistance of ordinary Portland cement is higher because of the availability of the Portlandite. That Portlandite will react with carbon dioxide to form calcium carbonate, so which helps with carbon resistance of normal cement concrete, OPC cement concrete. So then it increases it forms a denser surrounding outer of the concrete, so it delays the further carbonation of the concrete. But when we see blended cement systems, we will not have Portlandite available because the Portlandite will react with the reactor silica from the surrounding material to form additional CSH, so there will be no buffer available for the for carbon dioxide to react with. So it will react with the CSH, existing CSH. So the calcium from the CSH will react with carbon dioxide to form calcium carbonate, leaving the amorphous silica gel. Okay, so that does not contribute to the strength, and it affects the concrete integrity as well. Okay, so where we stopped. Okay, so more replacement leads to reduction in Portlandite. So the amount of Portlandite with 10% of silica fume will be more like it will have more Portlandite compared to fly ash blended cement concrete because it is replaced even up to 25 to 30%. And coming to pore refinement, cement concrete with silica fume has better pore refinement because it is a highly reactive pozzolanic material. So it leads to better pore refinement compared to fly ashes. So if the pore refinement is better, then it has better uh, resistance to carbonation. Okay, so I hope you guys got it right. Now let's move to the next question. Question number 19. Which of the following options will mitigate plastic shrinkage cracks in cement concrete? You have to find the correct answer. So please pick the right option here. Let me start the timer for 30 seconds. Time's up. Let's see the class response and see the solution. Okay, most of you picked all of the values. Okay, let's see from the boards as well. Okay, most of you have picked this is the mixed response, but most of you have thought all of them. Okay, I don't know how come increasing water to cement ratio will really help. Okay, let me in the poll and let's see the solution. So increasing the water to cement ratio does not help with plastic shrinkage. Okay, there will be more water available, and if more water is available, there will be more drying out, so there will be plastic shrinkage as well. Okay, now let's see the solution. The correct answer is both option B and C. Okay, so increasing the water to cement ratio will not help to mitigate plastic shrinkage cracks. Addition of fibers to concrete. We all know that concrete is weak in tension. Okay, so once shrinkage occurs, drying of water occurs when concrete is in plastic state, still green. So loss of water from the concrete leads to shrinkage. That is called plastic shrinkage. Okay, so adding fibers will increase the tensile strength will add to the tensile strength of the concrete. So obviously, if there is some cracks happening, it will try to mitigate the cracks because of the addition of fibers. And moving to option C, controlling the rate of evaporation of water from concrete surface. So obviously, plastic shrinkage cracks occur when there is a large surface area. Okay, if the concrete is very bulk and if the not much surface is exposed to the environment, uh, then there is not much concrete. If more concrete, we can consider a concrete deck, bridge deck. Okay, then we can see more concrete surface is exposed. Okay, and if you consider a foundation type of structure, then not much concrete is exposed to the environment, right? Concrete surface is not much exposed. If you consider bridge deck, then most of the surface will be, and if you consider industrial flooring and all, so the concrete surface area will be exposed to more. So in such cases, we have to control the evaporation rate from the concrete surface when it is still in plastic state. So that will that will mitigate the plastic shrinkage cracks. Okay, so the correct answer is both option B and C. I hope you guys got it right now. Now let's move to question number 20. This is the last question for this week. So the statement is temperature does not affect the creep of concrete. That is the statement. Okay, but let me start the timer for 30 seconds. So how does if we increase the temperature, decrease the temperature, what will happen with the creep of concrete? Does it really have an effect on creep of concrete? Here I said that doesn't affect the creep of concrete. Is it true or false? The correct answer is the class response. The correct answer is false because increasing the temperature will increase the creep of concrete as well. Okay. So temperature does affect the creep of concrete. Now let me start sharing the screen because that was the last question. If still guys you have any doubt, we can discuss or else the class is over. Okay, most of you given the right answer. That's nice. And tomorrow there is a live session with the professor. I hope you guys have all received the mail. Please come to the live session and post your queries. You will get the appropriate answer from the post instructor as well. From answer. Okay, let me end the class now. I know it's still Diwali in some parts of the country, and you guys are still available for active participation. Thank you so much. Let me end the class here. It was a nice journey with you guys. And this is the last problem solving session for you. And tomorrow there will be a live session with the course instructor. Please be present for the live session. And then I wish you all the best for the exam as well. Thank you.